Spanish, and later I will switch to back to English. Muy buenas tardes. Muchas gracias por el interés en estas actividades del Colegio Nacional. El colegio celebra este año su 75 aniversario y estamos pues muy honrados de que la reunión del Consejo Directivo de la Unión Internacional de Geodesia y Geofísica celebre aquí en México. Entonces, nos da muchísimo gusto. Ha sido una semana muy interesante. El Consejo Directivo de la Unión es un grupo multidisciplinario y que además viene de muy diferentes países. Creo que todos vienen de un país distinto, entonces realmente nos da mucho gusto tenerlos. La Unión el año entrante celebra su aniversario 100, entonces es de las uniones científicas más antiguas, es una unión, al rato vamos a ver la segunda conferencia, cómo está conformada y cuáles son los programas y planes de colaboración internacional. La colaboración internacional es ahora la actividad más importante en ciencia y la ciencia y la innovación son los motores de cambio, de transformación en las sociedades, en la nueva sociedad del conocimiento. Entonces, realmente nos da mucho orgullo el tenerlos aquí. Les agradecemos muchísimo a todos ustedes por decidir el tener la reunión del Consejo aquí en México. Vamos a tener como parte de las actividades dos presentaciones. La primera es a cargo del presidente de IUGG, el doctor Michael Sideris. El doctor Sideris es profesor en la Universidad de Calgary, en Canadá, y con la Universidad de Calgary, de hecho con toda la Universidad de Alberta, son los programas más grandes que tenemos ahora en energía. Las cantidades asignadas a los proyectos de colaboración con Calgary y con Alberta son de los más grandes que se han tenido aquí en el país y intervienen varias de las universidades, incluyendo la Universidad Nacional, la UNAM. Entonces, es un gusto doble el tener al profesor Sideris aquí con nosotros. Él estudió la licenciatura en Ingeniería en la Universidad Estatal de Atenas y después la maestría y el doctorado en la Universidad de Calgary. El doctor Sideris ha tenido una carrera muy exitosa. Él trabaja en la parte de geodesia, en la parte de observación de la Tierra usando métodos satelitales, que es de hecho la presentación que tendremos el día de hoy. Y el doctor Sideris, como parte de las actividades, ha estado y participado en proyectos internacionales en una gran cantidad de países, lo cual pues yo creo que es parte de lo que deben de hacer los de la Unión Internacional de Geodesia y Geofísica. Entonces, sin más, yo creo que vamos a comenzar con la plática de él. También, pues, muchas gracias a todos los que están conectados vía remota, que ahora es complicado con el tráfico. Okay, sorry about this long introduction in Spanish, but we are very pleased having the meeting of the Executive Council here in Mexico, and congratulations to the Union for the 100-year anniversary. We are looking forward for the assembly in Montreal in Canada next year, and most of the students will be connected by streaming because of the traffic, and the university campus is in the southern part, is relatively far. And welcome again to Mexico, and hope the meeting has been very successful, and we are looking forward for expanding and continuing the collaboration. Okay, thank you.
this. Okay, you can hear me, I think. Well, thank you. Okay, thank you, Jaime, very much for your nice introduction. I would like to, first of all, thank the Colegio and the National Committee of Mexico to IUGG for this kind invitation for our bureau to have the meeting here. We are very glad to be here, and we're really enjoying both these beautiful surroundings and the city of Mexico as well. For me, it's the third time in Mexico, the second time in Mexico City. The first time actually was with our university again for a big program that we had at the time with a large number of CONACYT-funded students from Mexico and the rest of Central and South America, which I think it continues, although I believe the amount of funding has been reduced, but that's life currently, not only in Mexico, South America, but also in Canada. So today, what I would like to maybe talk about a little bit is on satellite Earth observation, in particular with respect to what IUGG does and how it is involved. So I would not be talking about my own personal research, if you like, but I would like to give a more general talk on satellite Earth observation and try to fit this within the IUGG structures and the IUGG associations. So I would not take too much of your time, but at the beginning I would like first to introduce the union and also its 8 different associations. And then I will just, again, talk a little bit about how geosciences, and in particular Earth observations and geoscience connect, give you a little bit about the needs and the unique contributions that we made as a union and as an association. And then I would like to give you some relevant examples. Again, they are from all over the geoscientific spectrum, if you like, in particular on climate hazards, hydrology, oceanography, and so on. I chose these particular ones, as you will see, trying to fit them into the general discussion that we have these days internationally about the Paris Climate Agreement and the essential climate variables. And so I will take this framework, if you like, to talk about some of the examples here. And then talk a little bit about what are the current challenges when we talk about satellite Earth observations, and I'll give you a couple of particular responses that IUGG has led. And finally, I will give you a few closing thoughts. So I think Alec, who is our Secretary General, who will talk after me, will give you a lot more information about IUGG and particularly its history. But here I would like to just give you just a few key points. We were founded in 1919, as you can see. So next year we have our anniversary. We are a little bit older than the Colegio itself, but and this is also hosting us here and having these talks is part of the national, if you like, celebrations that we have asked our national committees to IUGG to do so that they can introduce IUGG more to their own audience and do small events like these ones locally. So IUGG, as you can see, is dedicated basically to advancing, promoting, and communicating knowledge in the Earth system and its space environment and the change that we are observing. It is a founding member of the International Council for Science. As you know, now it's called International Science Council, and it comprises national membership as well as some affiliate members that you see on the right-hand side of the screen. I will not go through all of this, but so that you know what IUGG is about. If you look at the mission of the union, is basically dedicated to advancing and promoting and communicating the knowledge that is related to the Earth system, its space environment, and its temporal changes, basically, and the effects, of course, and the causes of these changes. In the end, the idea is not to do science for science only, but also to contribute to the societal needs of society as much as we can, and communicate this knowledge to the government and to the policymakers so they can make informed decisions when it comes to things like climate change, hazards, and so on and so forth. As an organization, of course, we advocate non-discriminatory practices. We're free and open exchange of data information as well as scientists, which has become an issue currently. And we collaborate with the International Science Council and the United Nations, as well as many other organizations, to develop research programs, to have geoscience projects, educational projects, but also develop scientific standards and services that are used not only by scientists, but also by government organizations, and in some cases, the public itself. We are basically a union, an umbrella organization, if you like, of 8 scientific organizations. I will show them to you here. As you can see, we have 8 associations on cryospheric sciences: geodesy, geomagnetism and aeronomy, meteorology and atmospheric sciences, hydrological sciences, physical science of the oceans, seismology and physics of the Earth's interior, and volcanology and chemistry of the Earth's interiors. So, as you can see, we cover a very large area of geosciences. The one that is probably excluded here is the geological sciences, who have their own scientific union. So, as I mentioned before, we collaborate with a lot of organizations around the world to develop information and then help them develop policy. Here is, for example, a report on extreme natural hazards and societal implications of them that IUGG has led in the past. Maybe Alec will give you a little bit more information about this particular project. And related to that, as you can see on the left-hand side, this was developed into a complete book that was published in 2014. And then in 2016, there's another book on dynamics and predictability of large-scale, high-impact weather and climate events. And this year, actually, as we speak, we have a new book published on global change and future Earth, where we give the geoscientific perspective, in particular from IUGG. So, how to relate the geosciences to the satellite Earth observation? Why do we need observation from space? Basically, if you look at the figure on the right-hand side, you can see that I have tried to capture, actually it's not my figure, to capture the contribution of various satellite missions to geoscientific aspects. So various science areas that you see, including a lot of them that do have very strong societal implications, like sea level rise, for example, and the melting of the ice caps and things like that. So the idea in the end is basically to use this information that we produce and we provide for the good of society. So to meet the societal needs that you see here. In particular, if one talks about hazards, we need to be able to assess them, see if we can predict them, and develop mitigation policies and government policies for minimizing the effects of these hazards. So in general, one can say that today the space observations of the Earth, if you like, have become nothing else but a indispensable remote sense tool that help us produce more science and, of course, inform society and societal needs. So, with that in mind, I would just give you a few, if you like, general examples for the rest of my talk. Just to give you a simple idea on glacier hazard detection here, I am giving you a particular example from Tibet, where by use of optical and synthetic aperture radar images, it was possible to basically predict the melting of these glaciers, basically the collapse, if you like, of these glaciers, and inform the people in the government, the people in these regions, to be able to minimize the effects on the population of these hazards. Just as a general information, what are the unique advantages of doing this from space rather than using terrestrial observations or in situ observations, if you like? First of all, we can have global coverage by using satellites in most cases. I will give you a particular example on aerosols, for example. We can have continuous monitoring in many cases. For example, greenhouse gases, I will show you an example, and water vapor example that is important for weather prediction and other applications. We have a lot of advances, of course, in technology as well as in methodology, and a large set of new and past satellites that we work with. I will show you a particular example here where we have now reached a level of, if you like, resolution and accuracy that, the noise of the past has become the signal of today, because we can extract a lot more information from these data sets. And I will show you an ocean circulation example here. We are able also to separate very, very small signals, in particular important for hydrology and water cycle monitoring. And of course, we are not static anymore. We can now observe and in many cases even predict dynamic changes. And so this is extremely important for applications like the environmental ones. I will show you one particular example on integrated ice melt, which contributes to the rising of the sea levels globally. And of course, we are complementary to the terrestrial and oceanic systems. And very important today, we have started seeing the development of low latency products, meaning that within an hour or less, we can really have important information for the public and the policymakers. I will show you one example with precipitation here, but there are many other ones that one can relate to climate and hazards. So if you like, we have reached an era of four-dimensional geoscience in general and Earth monitoring, which is enabled by these satellite missions. And by four dimensionals, I mean the time changes of all of these effects. We're not only talking about the spatial distribution or the spatial effects that we see, but also the changes with time. So if you look at now our associations and various satellites, I have just listed a few here. This is not an exhaustive list, and neither is it a one-to-one correspondence between our associations. But for those that can recognize some of these missions here, you will see that we include all sorts of missions, some that are monitoring the cryosphere, for example. There's laser and radar altimetry satellites. Some of them are gravity satellites, some of them are optical satellites, some are synthetic aperture radar satellites, and so on and so forth. Some of them are atmospheric monitoring satellites. So it's a huge arsenal, basically, that is used by the geosciences to be able to produce the information that the public will need in the end. So as I said, I will just show you a few examples related to the Paris Agreement. And so if you look at the Paris Agreement and you see, if you like, the major 5 areas that it tries to contribute to: adaptation, loss and damage, capacity development, national response, and mitigation. The Earth observations, if you like, are the baseline. They are basically the base, the pillar, if you like, on top of which you can produce information and build on the other 5 regions. So this is the part that we contribute mostly, if you like. We provide the scientific information, and then it's used for the societal implications, as well as the development of policies by government agencies and so on and so forth. So if you look at the essential climate variables, I will show you some examples of those. They start from sea ice, as you can see, sea level, they go all around, all the way to the atmosphere, clouds, aerosol, glaciers, ice change of the sea levels, land coverage, and so on. I won't cover all of them. Obviously, we don't have enough time here, but based on that, I will just show you where we can contribute. So I have given the same example, the same figure as before, where I try to map some of these essential climate variables to the contributions that are coming from the various associations of the IUGG. And again, it is not an exhaustive list and is not a one-to-one mapping all the time, but you can see that there is quite a good correspondence. Glaciers and ice sheets, for example, I have them next to the International Association of Cryospheric Sciences, right? Ocean circulation next to the International Association of Science of the Oceans, and so on and so forth. The ones that have been bold are the ones that are the direct essential climate variables. The ones that I have in parentheses, for example, are, if you like, indirect essential climate variables, or contributing to the information that we need for the essential climate variables. So some examples. The first one is greenhouse gases. I have here pollutants and aerosols. I show you basically how methane and CO2 are basically changing in time. You can see from 2009 to 2016, the increasing trend that we are all basically familiar with, more or less, which one can relate also to temperature changes in the planet, as well as the other climatic changes that we are all observing, and contribution from various satellites. I told you that we can also do the same thing with aerosols in the beginning of the talk. Here is an example that shows the global distribution, if you like, of the various aerosols in the planet. And a lot of this information is produced by combining or assimilating, if you like, in situ observations with satellite observations as well. Another example, water vapor change directly computed from GPS or GNSS observation, global navigation satellite systems. On the left-hand side, you see a set of tide gauge networks that are globally available and some of their contributions to not only changes in the sea level, but also if you analyze the GPS data to the water content of the atmosphere. Another one that we contribute to, for example, is this global climate, Global Climate Observatory System, a reference upper air network of GRUAN, 26 stations that are contributing to GCOS, which is one of the intergovernmental bodies on climate change research. An example from global precipitation. You can see here how it is changing very quickly. This is one of the recent low latency products. You can see that it is updated practically within 4 hours, and then you have continuous coverage, both in time and in space around the whole Earth. Water cycle from space. This is an area which is more related to geodesy, so forgive the geodetic bias, if you like, of some of these examples, because I am a geodesist after all, so excuse me for that. GRACE is one of the satellite systems that is monitoring temporal changes of mass redistribution within the Earth system. And here, basically, you can see, if you like, observed gravity changes converted to hydrological changes. Okay, you will need a lot of additional information, obviously, to be able to do that. But if you look here, you can see the floods and the droughts in the Amazon area, for example, and other parts of the world. And you're all more familiar, perhaps, with some of these more recent applications of the droughts that we have seen in India in the last decade or so, or the droughts that California is suffering at the moment. You have all seen the effect of the devastating fires very recently in California because of that. If you look at the water cycle itself, for me, this is maybe one of the most illustrative type of examples, because if one writes the water balance equation down, so you basically have the change in the water, in the soil moisture, in the soil water and the groundwater, as the difference between precipitation and evaporation and discharge, you can immediately relate each one of these components to contributions from various satellite systems, which is very interesting to see. One of them, for example, that you see in gray is the total mass change with time that comes from satellites like GRACE. But if you are interested in the individual contributions from the soil moisture, the surface water, and the groundwater, the only way to separate it is to have additional information that may come from additional satellite systems or in situ observation. So I think you can see in one very simple example here how many satellite observations, satellite systems are contributing to the solution of a very simple equation like that when one wants to do the water balance globally or for a particular region or even for a river basin, something as small as this. Ocean circulation, the one I told you before. Here, if one looks at the geostrophic surface currents that we had a few decades ago, this is basically from an Earth gravity model in 1996, or maybe it was at the end of the 90s. And if you compare it to what we have today with new satellite systems, you will immediately see that this looks like total noise. You cannot even identify any of the currents and so on. While the other one, on the right-hand side, easily you can identify at least the major currents that are known at the moment. So this was made possible through improving not only the gravity field of the Earth, but also the information about the changes in the mean dynamic topography of the sea surface. So if you look at the gravity models that went into it, you see that they're now a lot more detailed. You can even pick information that is very local, caused by mountain ranges or by ocean ridges or stuff like that we could not possibly see before. And then if you use a combination of gravity and satellite altimetry over oceans, you can develop very detailed dynamic topography models where you can see how the sea surface is changing, both spatially and temporally as well. Another example that is very illustrative in terms of the integration and assimilation of all of these systems is the integrated monitoring of the ice mass changes as well as their contribution to the rising of the sea levels. So if one looks at this very general figure where it tries to show, if you like, the water circulation and exchange between atmosphere, land, ice, and oceans, if we want to be able to separate these effects, we would need information from a lot of satellites. Satellite altimetry on the left-hand side, ocean monitoring that comes typically from oceanographers to help us identify and separate some of these effects from each other. Terrestrial networks of tide gauges, like the one I showed you before, as well as GNSS stations on tide gauges. You need geodynamical modeling in areas like in Canada, where I come from. We have a lot of signal coming from the post-glacial rebound of the land that was basically suppressed around the Hudson Bay area. After the last ice age, it has started rebounding. It is a signal that is very observable. If you are observing the coordinates of a station, for example, you see 1.5 centimeters per year, very easily detectable by GPS, for example. And so it cannot be ignored, it has to be modeled. Gravity satellites like the one I mentioned, the GRACE one, can give us a lot of global information about mass redistributions. And of course, in the oceans, we have the Argo floats and other in situ pieces of information that help us identify some of these effects. So it's a combination of, if you like, of a large set of not only satellite information, large set of sensors, but also in situ information, as well as various models for both for the sea level and for in this case, the geodynamic effects. If you try to see how this looks in terms of sea level change, you may have seen figures like that show a sea level change trend of about 3 millimeters per year in the last couple of decades, for example. Now, if one wants to separate how much of this is coming from thermal expansion, for example, and how much of this is mass added to the sea surface, to the sea from the melting of the ice caps, the only way to separate it is to use complementary information. So from altimetry, that measures how the sea level surface is changing with time, you can get the total blue line. But if you go to separate how much of this is caused by new mass, then you need information that comes from gravity satellites like GRACE. And if you want to find out how much of this is thermal expansion, for example, you need the in situ information from the Argo floats and stuff like this. This has helped us create very, very detailed models now of the sea level changes, as you can see here across the globe. These are updated almost annually or biannually now from geodetic only information, and the oceanographers at the same time are producing their own models from independent information. Ice mass loss, if you look at the Arctic, for example, I can show you some changes in time of the Arctic from satellites like Cryosat and IceSat that are measuring this. Some of you may already know that the Arctic ice is thinning and is getting less and less, especially in the summer regions. Now they have started cruises in the Arctic because they can basically circumnavigate this part that was not accessible in the past. So we're losing a lot of mass. On the right-hand side, you see a more detailed picture of Greenland and the Canadian Arctic coming from satellite gravity information. And on the bottom of it, you see these two areas, this one, the south one, and the north part, coming from altimetry information, where we, first of all, measure the changes in the surface of the ice. We convert that to a volume change, and then if you have a density model, you can convert it to mass change, of course. And you can combine the two to see how much mass is lost. And here I'll show you some of these results in Greenland, for example, where you all have seen these types of graphs in the past, typical figures of 80 gigatons per year of change of ice mass loss, right? So it's quite significant. And of course, in the Antarctica area, also we have seen these types of effects and how the ice mass is reducing from 2003 here to 2013, you see, in this particular graph. So one more, maybe I have this and a couple more. I recall if there's more than this. Tsunami detection. And all early warning systems, particularly important after seismic events like the ones we have seen in Southeast Asia and so on, right? Here you see an old figure that is very illustrative. Actually, this is the earthquake that we had in the Indian Ocean in 2004. You see the wave propagating. The green line is just a pass, so it's the track of one of these altimetry satellites. So if you happen to catch this wave, you can see immediately there is a crest here and so on and so forth. So you can see the wave propagating. The question is, can we do it in real time? Of course, at the moment we cannot unless we are very, very lucky, all right? And we do it in real time here, and then we have the information before it reaches India or something, all right? So it's near real time, but not real time exactly at the moment. So together with UNESCO and the International Oceanographic Commission, we also have contributed to the international systems for monitoring the earthquakes and the sea level activities related to that particular tsunamis. You can see a very, if you like, complex figure there that includes everything from satellite communications to tsunami detection sensors on the surface of the ocean. At the bottom of the ocean, you have pressure sensors and so on related to that, seismometers as well for the seismic activity. So it's a combination of sensors, again, really complex. But we have reached a stage now that we do have around the globe various tsunami warning systems. You can see some of them here in North America, Central America, and South America, Mediterranean area in Europe, Southeast Asia, and so on and so forth. So we have reached a state that we can really have an early detection system, very important to alert the public in these types of events. Okay, so what are the current challenges that we have remaining, if you like, in this type of applications through satellite observation of the Earth from space? The reliable detection of small signals that are long-term in nature. And that implies that we need uninterrupted long-term series and, by extension, satellite missions that would allow us over decades to be able to monitor this. Of course, we need a lot of complementary data, as I said, to be able to identify and separate these particular signals that we see. Fast detection and quantification, very important. You see an effect here, seismic wave, if you like, propagating in the southeast part of the Mediterranean. We need real-time processing as much as possible, in particular for events that have to do with natural hazards like tsunamis, earthquakes, floods, and so on. I have not mentioned much about space weather, and maybe I should, because this has become a particularly important, if you like, hazard for not only communications, but navigation and energy systems and all the rest that are disrupted in the case that we do have events that have to do with solar cycles and space weather that interrupt these processes. Third one, the one that I mentioned before, and I showed you some applications, we have to be able to both integrate or assimilate these complementary signals together to be able to produce, if you like, the best science or the most reliable results that we can, and at the same time separate the smaller signals that are aggregated, if you like, when we observe something from space. So the sensor combinations and the multi-satellite data is particularly important in this particular case. And finally, but definitely not least, is the huge amount of information that we have. And you know that there is a lot of work done internationally now about handling the huge data set, being able to store them, process them, provide easy access to them. But beyond that, and probably more importantly for us as a union, is to be able to provide information about, standards and requirements that are universally accepted. I don't think we are there yet, but we are trying our best to contribute to that effect as much as we can. Now, being a geodesist, I put another requirement on top of everything else, which is basically the need to have a very precise coordinate reference frame where we are able to represent all of these signals and scientific results spatially. All right? This particular reference frame has to be reliable, stable in time, so that we can trust it when we talk about these very, very small signals that we see. Sometimes the deformation in the reference frame itself are bigger than some of the signals we try to separate out of the Earth observations. So it's particularly important to be able to have this as well as we can. So as IUGG, we have basically, if you look here, been successful through one of our associations, the International Association of Geodesy, to convince the United Nations to have a resolution that says that it is particularly important for all countries to share data and information that have to do with global navigation satellite system data, and be able to share them openly so that we can, as a global community, have a global reference frame and regional densifications so that countries can take advantage of those, that we can all trust, and we can use it to represent our scientific data and results as well as we can. It was also a resolution in the last IUGG General Assembly in Prague in 2015. Another one which is important here is the one that we put on the need for future potential satellite missions, so gravity and magnetics in this particular case. Some of the existing ones were CHAMP and GRACE and GOES and SWARM at the time, and now have the GRACE follow on. It was just launched last month, I believe. And so the idea was to convince the space agencies to ensure that we have continuity in satellite missions, so that we have this possibility of long-term, we're talking about decadal scales plus, right, for all of these effects. So the question is that enough, or now as IUGG or as associations, we need to talk about other types of satellite missions that have to do maybe with the atmosphere or the oceans and so on and so forth. I think personally the oceans are quite well covered, because the altimetry satellites have been renewed, if you like, over several decades, and more planned. I will show you a figure in a minute. So in closing this, just to leave you with a few thoughts, it is important to have these sustained long-term operations. We need to go beyond the current satellite missions that we have now. I show you some of the gravity and altimetry satellites in this case. And as I said before, the space agencies are delivering in that respect. I mean, given their reduced budgets at the moment, I think they're doing the best they can. So we're good. If you look at, as an example, this is from 1990, 91 in this case, various missions for monitoring the level of the oceans. And this says we're here now, this is 2017, well, now we're in 2018 already. But this, as you can see, we have not only an uninterrupted series, but also overlapping in terms of time, which is important. Yeah. Even Sentinel 3B here, it was launched in last April. So these satellites keep coming. I'm not sure if some of the other ones will have the same luck as this one, but we're hoping. We're always pushing the satellite agencies space agencies to do that. So finally, and in closing, long-term satellite observations and missions are extremely important, as well as sustained terrestrial informations and networks. We should not be forgetting about those, because we need a combination of the two. We need to integrate a diverse set of data and observations, as I showed you in some of these applications. In particular, if you want to tackle problems like the complex climate change and its effects that it has on society. We need to have relevant policies that are informed by Earth observation data and results that we produce as a scientific community. So you know some current politicians that don't believe in any of this, right? So I think we should all try to influence as much as we can our politicians, because that is extremely important, and our contribution is important and will be, I think, much appreciated by the general public in the end, not just the politicians. And finally, and important, open access both to the data as well as to the scientists to move around freely, promote their results, and so on and so forth. So, with that, I'd like to thank you for your attention and invite you to our General Assembly, which is next summer in Canada, in Montreal, in July, as you can see here. This is our 100th year, so we will be celebrating our centennial anniversary then with all of our associations at the same time. And we also have a nice event at UNESCO in July of next year, where we bring that, if you like, to the attention at a much higher level of the broader community, not just the geoscientists themselves. Thank you very much.
Comentarios pueden ser en español. Perfecto, muchas gracias. Bueno, preguntas o comentarios si pueden ser en español o en inglés. Well, I will start. It's interesting that for the coverage, the resolution of the satellite data is improving. It's really amazing. And how much are the governments using the data? Because it's important for planning, for natural hazards, for some now the climate change effects and so on. And but how much are the governments really using this information?
The real answer is not as much as they should. Okay, and I'm saying that coming from Canada because the governments have their own agendas. Don't forget. All right. And although the Canadian Space Agency and the government agencies know about all of this, in many cases they tend to ignore it. First of all, in Canada, if you talk about climate change, in particular parts of Canada, it's a no-no, right? Because it's an oil-producing country, and so they don't want to hear too much about this. But even the scientists that want to hear about it, I think they're not doing much from the government side. And the reason in many cases is they have invested interest in some particular satellites. For example, in Canada, it's all about RadarSat, right? Which is an important satellite mission. It's been continued, but that does not imply that they should not, pay attention to what the other satellites can provide and so on. Thankfully, we are associate member of ESA, and through that, we have the option of influencing them a little bit to be able to see the general picture that they presented here, not just what satellite information they can collect from RadarSat. At the moment, unfortunately, and shame for Canada, they are selling this data. Okay, and this has changed in many parts of the world. ESA, for example, has a policy that they do not sell the satellite data they produce, right? It's freely available. Canadian Space Agency still wants to make money out of it. So the answer is not as much as they should be paying attention to this data and using them, unfortunately. Maybe other parts of the world have much better policies. As I mentioned, in Europe, I know the European Space Agency has a good policy of open data access and so on. How much the governments are using it is a question. But that being said, we should not be forgetting that there are organizations internationally that make very good use of this data. Typical example is World Meteorological Organization. Okay, they use all of this data to good effect. But if you look at more of the local governments and the national governments, in many cases, not as much as they should. And I think we should not take ourselves out of this picture. I think it's partially our responsibility to convince them to do so. And as scientists, typically we do not do a very good job in selling this part to the governments.
Muchas gracias. A nivel pueblo, ¿cómo se puede contribuir a nivel mundial? Porque muchas naciones que son potencias les interesa un cacahuate. Simplemente quieren su mejoramiento personal y se acabó. Gracias.
Okay, so if I understand the question right, it was how the individual people can help convince the government to use this type of information. Was that the question? More or less?
Yeah, more or less.
Yeah. Well, I think as an individual, it's very hard to do it, right? Unless you talk to your local politicians. Okay. But don't forget, we are here representing union and association, and we have these bigger bodies that can advocate, both in the actual our own governments, but also globally, that governments pay serious attention to the scientific results. We need to be as clear as possible to give as reliable information as possible to them so that they can make these types of decisions. Now, sometimes they will, sometimes they won't. You know that there are some countries that don't want to hear about science because they know everything, right? And so there's nothing happening there, unfortunately. And these are big countries around the world. But I think as a union and as an association, we have the responsibility, and also we have it as part of our mandate to inform public policy. And so we try to do it as much as we can. Thank you.
Hola, buenas tardes. Es muy interesante la plática. Soy estudiante en la Universidad Nacional Autónoma de México. Hay algunos datos públicos que están para gravimetría y magnetometría en la red por la Universidad de Texas, me parece. ¿Hay forma, digamos, de tener un contacto más cercano para tener datos de métodos potenciales de mayor resolución con el apoyo de ustedes?
Okay, I was asked to repeat the question. So the question was if there is a possibility to have access to the data, in particular to the ones that are provided by some universities and some other places internationally. Is that the correct question? Okay, so I think all of our associations have services, and some of the services have portals where you can go and access this type of data. Okay, if you're looking for gravity or magnetic data, unless they are proprietary, they are available to you. Okay, if you are interested, you told me you're a student, I can later on provide you with the links to these places, so you can go there and download it yourself. Okay, some of the other organizations globally, for example, the Group on Earth Observation also has started a portal now where you can go and download data that are important for your research. Unfortunately, the only problem with this in both cases is standardization. Okay, the data are not in a standard format that everybody can download, understand, and use immediately. We're not there yet. But for university research, you will have access to a lot of this data. If you want me to give you particular links to the data that you mentioned gravity and magnetics, if I remember correctly, after the talk, I can provide you some link.
This is more a comment than a question. You mentioned in passing sensors, and I think one of the spin-offs of the Earth observation program has been the development of miniature sensors that have revolutionized, life for all of us, our smartphones and all kinds of other things that we now depend on. So I think this is something else that we can point to as one of the important aspects of this program.
That is correct, and I did not mention it, but now if you like, most of the space agencies are looking at mini or nano satellites, not only the sensors that you mentioned. So the satellite observation is going to be as compact as possible, typically because it's much cheaper to launch and operate, and there's a lot of effort that is made into that. Even some of the satellites in totally different applications you may have seen have been produced and they have landed on asteroids. Okay, and there we're going into mining of asteroids and things like that. So it's the field is broadening up, the applications are broadening up, the technology is enabling us to do a lot of these new things.
Well, actually, in Mexico, there is a lot of interest in the microsatellites. And the university, the Tsunami, has a project, and because of this possibility, and also related to the telecommunications, Mexico created the Mexican Space Agency just a few years ago. And it's looking for collaborations with Europe, the European Space Agency, and particularly with NASA, and eventually with China and Brazil and the rest of the countries. Well, thanks very much, Michael, again, and we look forward for attending the General Assembly in Montreal in next summer. That will be really interesting for us. And now we move to the second presentation, and the second presentation is by Alik Ismail Sadeh. He is the Secretary General of the International Union of Geodesy and Geophysics, and is the newly elected Secretary General of the International Council of Science, which is the IUGG, the Council of Scientific Unions, and the merger with the Council of Social Sciences. So it's perhaps it's the largest organization in science we now have. So we are proud that in the IUGG, we are proud that Alik is the newly elected Secretary General. So congratulations, Alik. And Alik is a professor in the Institute of Technology of Karlsruhe in Germany. And wow, I realize I will continue in English. Sorry about this. Alik got his bachelor degree in mathematics in Azerbaijan, in the Baku University, and later on a master and the PhD in a master in the Lomonosov University and a PhD in the Russian Academy of Sciences. And Alik has a very distinguished career and has dedicated part of the time to the international collaboration. He has already been in Mexico, and we had a lot of joint projects together. And he's very much interested in promoting collaboration with the developing countries. And in his position as Secretary General of IUGG, he has been instrumental in creating and developing projects on the natural hazards and prevention. And he's also the chair of the Institute of Earthquake Prevention for the Russian Academy of Sciences, and the chair of the dynamic computational dynamics.
Fantastic memory.
Oh no, not really. You do so many things that is extremely difficult to keep track. So we are very proud of having you here, and thanks very much. And the presentation is on the Centennial anniversary of IUGG and international collaboration in general. Por favor, Alik.
Thank you very much, Jaime. It's really enjoyable to be here, and the second time actually to give a lecture this wonderful auditorium, and which is a really public lecture. It's not only scientific, but it's a public lecture, and to appreciate to get feedback from those who are maybe not quite interested in science, but it's not really doing science. It's really a great pleasure to be here. And I would like again to join Michael in thanking the Mexican National Committee, and especially you for inviting us here to have our meeting, our executives meetings here, and to decide about the future of IUGG behind of 100 years.
Well, Michael Sideris gave you the wonderful overview about these observations in Earth and space science and how these observations help really scientists to do science, to generate new knowledge, and to contribute to the development of the future of the Earth. But today, I can tell you, it would be impossible to come to these great achievements without international scientific collaboration. Today, no any country, even the United States of America, with power, scientific power in the world, it in any way cannot do alone such a wonderful scientific work which are developing for many years. But the first question probably will be that when this international scientific cooperation started, it's a really very complicated question, and to trace the starting and the point, it's very complicated. But just to give two examples, one of the examples is something which is close to you. It's Alexander von Humboldt. When he visited Latin America, he returned back to Germany and convinced his colleague, and especially rather well-known mathematician Gauss, that we need to establish international magnetic union. They did. These magnetic observations were needed for the whole Earth, not only for some one country and so on. And he saw these abilities that scientists all over the world can contribute to the progress of science. Another example also is related to Germany. Probably I am living in Germany, that's why I'm biased by German examples. But at that time, Germany really was it was a place where the many international activity started to be developed. It was again something related to Gauss, but it was his student, General Weil, who through the King of Prussia invited the scientists of Europe to start the international association, which today is called International Association of Geodesy. It was more than 150 years when the International Association of Geodesy started. But this is just two examples. It's really very difficult to tell. However, if we will speak about this so-called modern international cooperation, I will refer to end of the 19th century. At the time when the very well-known geologist Zeus, Austrian geologist, suggested several academies to come together and to establish the association, International Association of Academies. And they started to think what they can do together. For example, 3 countries in Africa were divided between the 3 nations. It was Britain, France, and Germany. And they needed some type of a science diplomacy to bridge and to make measurements, geodetic measurements in these countries. And these academies, they helped to really fast to get visas at that time, and so on, to scientists to visit this country, to make measurements, etc., etc. And what is really was bad at that time, that is war came. Everything started to go down, all activities. First World War. But for me, starting point of today's presentation is 1919, because it's 100 years. And everything started for us from the inaugural General Assembly of the International Research Council. Jaime mentioned that it's recently International Research Council established. I will tell something. But it is a predecessor of this International Science Council, which was called International Research Council. And before it, the countries who were winners in the First World War, they decided that to establish this International Research Council. Not only academies comes together, but also those international associations which already were established and functioning at some level because of the Second World War. Many of them went down in their activity, to bring them together. And this was 11 countries who started, and at the General Assembly 5 other countries also joined this activity, and they came together and established International Research Council with several specific goals of this, or objectives, to coordinate international efforts in different branches of science application. That's one of them. To initiate of the formation of the international associations and unions deemed they be used to the progress of science. To direct international scientific actions in subjects which do not fall within the province of any existing association, and to enter through the proper channel into the relationship with the governments of the countries adhering to the council, to recommend the study or questions falling within the complete competence of the council. It was written in the Nature paper in 1990 by Henry Lyons, Sir Henry Lyons. You will see who was this person, but I would just tell that he was the first Secretary General of IUGG. And I'm very sorry, on the right-hand side, there is the historical photos. It is a building of the Academy of Science in Belgium, where this council was established, and below it is the first IUGG officers in 1990. Well, let's start with the milestones and with the steps of the development in IUGG. And in 1990, one of two first international unions established was the International Union of Geodesy and Geophysics and International Astronomical Union. And our union was established based on the already existing 6 international associations or grouping, or at that time was not only one had a name association, not others. And they decided to have them as sections. At the first General Assembly, there is a 7th section, which was called the Scientific Hydrology, were added in Rome. IUGG really spent the first period of time to the bringing together the scientists. It was not many activities, at least known to us historically, like today, like you will see later how much your activity developed. But one of the very important activity was to participate in the 2nd International Polar Year, which International Research Council and the ICSU later, at that time already was International Council for Scientific Union, set up. The sessions were renamed into International Association at the General Assembly in 1933 in Lisbon, Portugal. And after that, the development was rather well, from about 80 delegates who participated at the first General Assembly in 22 to the more than 800 people who participated in 1939 General Assembly in Washington. Unfortunately, this was the last assembly before the Second World War, and even more. It started at the 31st August, and the 1st September, the war was declared. Many delegates needed to leave to their country because they called back to their country. And one of the greatest person, I will show him, Secretary General of IUGG, Wittenberg, he really kept the IUGG survived through the war. And another thing, I will go down to the 1966, and then it's I will show some really distinguished leadership who contributed to the development of IUGG at this time. After the Second World War, we had an extraordinary General Assembly to really reactivate the activity of IUGG in Cambridge for the first. After that, and at that time, Could you believe how important was at that time IUGG that the UNESCO, which was just established in 2 months, signed working agreement with IUGG to work together. It was incredible recently when I knew about it. It was just a paper in Nature, another paper in Nature, which was speaking about this. IUGG was invited by UNESCO to contribute to the scientific development. And later on, we were one of the first organizations who signed the working agreement with the World Meteorological Organization, WMO. Definitely one of the major and shining at that time, the program which was established by the International Science or ICSO, International Council of Scientific Unions, and World Meteorological Organization, but by the initiative of the IUGG, was the International Geophysical Year. It was not only scientific program, it was not only the bridging the scientists from all over the world, it was a political event. For example, the first satellite ever started in 1957 and was dedicated to International Geophysical Year. It's not just something which was independent. It was specific dedication that within the geophysical year, the Soviet Union would like to start the new program of space research. And there is a cooperation with the International Oceanographic Commission started in 1960. And the first use of the present-day logo, it's a very interesting how it was developed. It was a Swiss colleagues who specifically developed this logo for the General Assembly in Zurich in 1967, and they introduced this logo to everybody, and that time to all delegates. But again, it's we cannot speak just about the events and events. We should look also who truly contributed to this international event. You know, the wonderful gentleman, first wonderful gentleman. Charles Lalleman was the first president of the Union. The Prince Albert I of Monaco. Today, it's, you know, probably, and maybe met, it's Prince Albert II. He's a grandson of the Prince Albert I, who was the first vice president of the Union and who was a really great contributor to the oceanographic studies. There is Sir Henry Lyons. I already mentioned his article in Nature. He was a Secretary General for 12 years. William Bowie, who is one of the founders of the American Geophysical Union, and which celebrate also in 100 years, but sometimes the leadership forget that it's a celebration of 100 years of AGU is because of the IUGG was established in 1990, and the US National Committee for Geodesy and Geophysics was established, and later part of this committee started to call themselves American Geophysical Union. Well, another distinguished scientist is here. Probably some of you know these great names of the great people. And there's, that's other people till the 1967 who contributed, and there's a very well-known Sidney Chapman. He was you know, so bright the scientist that he contributed to 2 associations of IUGG. He was the president of IAMAS, which is dealing with meteorology and atmospheric sciences, and president of IUGG, which is related to the geomagnetism and the aeronomy. And he was one of the founder, actually, of the International Geophysical Year, because he met the Berkman, one of the American scientists, and spoke to him about the possibility to generate the 3rd polar year. But they later decided it's better to call this International Geophysical Year. And you see the other, it's very well known, it's John Tuza Wilson or Vladimir Belausov. If you are going to the science, the history of science, you could see, you could observe that this is a 2 gentlemen. Were they really some type of the enemy of each other scientifically, but were very good friends, and they were president just after another, because it's Tuza Wilson was a proposer of the plate tectonics, And it's, Vladimir Belousov didn't believe until his end of his life that plate tectonics exists, because he was a physicist and he was really the person who was quite interested in the development of this. He understood this theory, but he thought there are all many others. That's very interesting how science is developing, yeah, especially in the area of geophysics. But another person is really very interesting. It's to see the name when I first time saw Jean Coulomb. He was a famous mathematician, French mathematician, but definitely it's with many applications in geophysics. And he was in France, it's one of the famous scientists, the president of academy and many organizations. He was a president of International Council of Scientific Union and other things. We can speak a lot about, but unfortunately not a lot of time. And Georges Laclaver was a very long period of time Secretary General of IUGG, and he was one of the person who made an excellent science diplomacy, because Americans wouldn't like during the geophysical year to contact Soviet Union, and they contacted Prime Minister of France and asked him, could it would be possible for you to contact the Russians, Soviet Union, and invite them to the International Geophysical Union, because without Soviet Union it would be not a real international union. And he called to Professor Laclaver and asked him to contact the Academy of Sciences of Russia, of Soviet Union, and this worked. He contacted the president of the Academy of Sciences. President contacted at that time Khrushchev, who was a general secretary of the Communist Party in Soviet Union, and Khrushchev told, yes, we will participate. That's something, it's historically really, it's quite interesting to see. Well, the union after the 70s started to develop interdisciplinary research with really very expanding this interdisciplinary research, bringing together associations. It was the first commissions which were ever established in IUGG was the Union Commission on Mathematical Geophysics. Then we established a cooperation with International Hydrological Program. The 1987, there is another second commission on study of the Earth's deep interiors was established. International Lithosphere Program was established together with International Union of Geological Sciences, and the first international terrestrial reference frame, which Michael specifically mentioned about the importance of this reference frame, was released by the International Association of Geodesy, our association, in 1988. Then the third commission on geophysical risk and sustainability, was established in 2000 as the legacy of the United Nations decade on the reduction of the natural hazards and natural disasters. And ICSO GeoUnions Consortium was established. And this is another set of the leadership of the union who contributed at that time. I would like to tell, specifically mention here the Baron Paul Melchior, who was a 24 years General Secretary of IUGG and significantly contributed to the development at that period of time of IUGG. And the other gentlemen you see here truly contributed to the development of IUGG. Now it is a period which is more or less related to my period of time in IUGG. I was elected in 2007, and it's that this year was really one of the famous year in our union, because the 8th association was established. And you see that it's International Association of Cryospheric Sciences was established in Perugia, in Italy. And in 2008, we introduced a grant programs in IUGG. We participated as a celebration of 50 years of International Geophysical Year in several years, which we initiated or we supported. It was Electronic Geophysical Year, Heliosphere Year, International Year of the Planet Earth, together with Jaime, who was also at the same time on the board. We really contributed very well. and the International Polar Year, which was a program of the ICSO and the World Meteorological Organization. IUGG in 2011 established a contact with Abdus Salam International Center of Theoretical Physics and signed first agreement to develop a joint geoscience education program. The Union Commission on Data Information was established, and many other things I wouldn't like just you see it, just to repeat what is here, were done within this period of time to really, they be in place and to be at the progress of science, because it's a structure which created to support and to promote science should not be the structure which is use the old methods and so on. We introduce a more progressive in terms of the management, administration methods to support scientists. Scientists who worked for association, who contributed to association, and who made science, who generated the great progress in scientific development. In 2013, we became a participating organization of the Group of Observations. We started a new program with the Cambridge University Press. We introduced a new awards, council. Most recent activities, our council becomes standing. And why, again, you can ask, what is the difference? Because time ago, council met only once 4 years, and any development in our union could be possible after the agreement of the council. It means that we needed to wait 4 years until the council will accept it. And then it's recently we decided, why? Let's make it the council standing, and in this case, council anytime will approve, will discuss, will approve the suggestions coming from the executive of the union, and to make the administration, to make this management of the union, as well as to help scientists with the progress. We introduced a strategic plan, new association logo was designed, and International Science Council was established. It is here also under the IUGG, because we are always working together with the International Research Council till the International Science Council, which is just recently established. And there is two major events which we will have next year to celebrate the 100 years of IUGG. And there is the last slide which I wanted to show you at this first my part of presentation, and you can see the difference of this slide from all previous, and could criticize IUGG. We were very much male-dominated union, and only one person was with us, female scientist. It was a Jocelyn, Secretary General, brilliant person, and it's managed during 8 years the union. It's very well, but we are improving it, and I will show you later about it. But again, what is the IUGG actually doing? It initiates, promotes a new scientific program, hold the scientific meetings, disseminate scientific knowledge and via publications and journals and so on. It's organize broad outreach activities, especially in the developing world. It's promote science education capacity building, encourage data collection and preservation, especially what Michael mentioned here, promotes public understanding of scientific activities. And it's a major activities which IUGG is doing. You already saw these things. That's our membership, which nowadays it is a little bit increased. And it's but during the, you see, for example, we have today 71, but during these 100 years we had about 100 and more members. But because of different, mostly financial issues in the developing countries, many developing countries not today with us because of, again, very strict policy in our constitution that after 4 years, if they the country not pay dues, they becomes not a member of the union. But we are now changing it. We are trying, even, thank you for accepting us here. We introduced 2 new sub-programs which should be definitely approved by the council, which will make our membership even larger. And that's very important. And also, as Michael told, in 2014, we introduced affiliate membership, and several organizations already joined us. This is something which you don't need to read. It's thanks to Franz Kuglich, who developed this very nice pattern of IUGG, because before it's not everybody knew what actually IUGG is. Except they knew that, oh yeah, it is umbrella for 8 associations. But what we are actually doing, it is first of all bringing this all association together, but each of them have their own structure, own regulations, own the even status and bylaw, which is definitely with close to the, I mean, it should not contradict the union bylaw. But the point is that it's many organizations, 100 organizations are IUGG brings together. I can tell you just a very simple. In IAMAS, which is dealing with the meteorology and atmospheric sciences, there are about 8, I don't remember exact number, 8 or 9 commissions, and only one commission can generate an assembly which will bring together more than 1,000 scientists. It is one of the commission of one of IUGG association, one of IUGG association. I mean, but also very important, IUGG brings this link between these associations, links through union commissions. Union means that all associations participate in the specific issues which is most relevant to society, like climate change, like, for example, geophysical sustainability, like data and information, etc. And also we have an inter-association activity, which means that several associations come together and generate a new activity. Another question, added value of IUGG. Many times people ask, okay, but what is IUGG? What is the difference between AGU, American Geophysical Union, EGU, which is European Geoscience Union, others, and IUGG or other international unions? But it's an important issue here. First of all, there is IUGG. In terms of IUGG, we are promoting basic disciplinary and interdisciplinary research. That's one of the important issue. We contribute to outreach program, and this is just abbreviations, but behind of the abbreviations I already told. A lot of interesting outreach activities like International Geophysical Year, International Year of the Planet Earth, and many others. It is outreach activities. It goes to people to explain what is the brilliancy of the Earth science, and to appreciate, and even government staff appreciate. It was some observations that after International Year of Planet Earth, there is a number of the students in geological department increased. I don't know, it's a correlate to each other, but what observations, published observations. Science for Society, we are doing a lot to really bridge the science with the policymakers, especially in the area which is related to climate, natural hazard, disaster, mineral resources, water, etc. Science for developing world. It is one of the most important, and not only we, but also geo-unions. I will tell you just in a few minutes what means geo-unions. And we are really bringing this state-of-the-art science to less affluent countries. That's another important issue. We are building capacity in these countries, and we're introducing a lot of activities related to science education in developing countries and less developed countries. Data information was an important thing, and Michael today mentioned specifically about this observational data and the services and how they contribute to progress of science. Scientific products, that is something especially important, because that is what unions doing, and what is no any other professional society like EGU, AGU, and others doing. We are generating these products like International Terrestrial Reference Frame, already mentioned, International Geomagnetic Reference Frame, joined in smartphones. Every smartphones today has this geo-ID. It's to measure, but it's probably kids who can tell it's more precisely how it's done. But anyway, it's a planetary system nomenclature and many other things which unions develop. IUGG plays important role in regulatory role in geoscience, particularly establishing terms and conditions of international research cooperation, setting the standards, nomenclature, and preparing universal tools, among all other activities. That is the geo-unions I already mentioned. It is the 8 today unions, which was the initiative of the International Union of Geological Sciences in IUGG, to come together, not just to do something independently, but to come together and to dedicate activity to the big issues related to all society. And IUGG also cooperate for many years with the other international unions who are not a part of geo-unions, like Mathematical Union, the Union of the Theoretical and Applied Mechanics. It's the true theoretical, let's say, unions, which makes very big link to, or created very big link to our union, because our union really, there is a union which used for many years the basic knowledge coming from the mathematics and mechanics and made proper use in their own investigations. Biological union, that's most recently we established also because of the food security. We established this cooperation with two unions like nutrition science and food science and technology. What is the goal actually of this cooperation? It's to promote and encourage fundamental sciences in the earth and environmental space and in the environment and space, to facilitate international cooperation, to enhance the operation of the union, on the knowledge about the experience of the union, and to speak on the behalf of unions to the Council, Science Council, United Nations Organization, and other global stakeholders. That is a picture which were taken in Taipei a year ago, and there is the participants of the two councils. It's the members of the two councils, International Council for Science and International Social Science Council, which they decided in Taipei that these two unions will, two councils will merge to create a biggest council which will coordinate activities not only in natural sciences, but on social sciences, humanity, and many other branches of science. Science is one. Today, this International Science Council, it has a 143 member organization, which means academies, research council, agencies, natural, 39 member unions, association, and 31 affiliate members. You see here that inaugural meeting in Paris, and was in July, and here you see officers. It's this gentleman, it's the first, it's the vice president, it's the president, and the different disciplines. It's the chemistry, president is a mathematician, our latest one, she is a treasurer, another is she is a physicist, and vice president another, she is social scientist. Then we have a president-elect. He is a medical and biological scientist, and he also was just retired in July before he was elected. He was a science advisor to the Prime Minister of New Zealand. Well, international cooperation, it is really important. It is a topic of what I am speaking today, and it is important for all science. And how IUGG dealt with these things during the 100 years. As I already mentioned, we established the first organization, established a cooperation with UNESCO, with WMO. But not only we cooperated with this UNESCO organization or WMO, we also established a contact most recently with the Intergovernmental Panel of Climate Change, with the International Civil Aviation Organization, and with the UN Geospatial Information Section. Also, we cooperate with the many interdisciplinary bodies of International Science Council. There is also, most of them were established after the International Geophysical Year, for example, like COSPAR, Committee on Space Research, or like the SCOSTEP with the Scientific Committee on Solar Terrestrial Physics. Also, we cooperate with other, you see here, I not go this, but we have also other, so-called other, which is not under UN or under the ICSO former ICSO organizations. Others mean, for example, there is comprehensive, it is the next one. There is a consultation, it's a committee commission on the time and frequency, and some others that already I mentioned, the GEO, and this is an organization also one of the first organizations scientific who started cooperate with the Preparatory Commission for the Comprehensive Nuclear Test Ban Treaty Organization, or IUGG, especially our seismologists, who really introduce new methodologies how to detect the underground and the underwater and other nuclear explosions. They are definitely our partner are the American Geophysical Union, Asia Oceania Geoscience Society, and European Geoscience Union. That is some just show the new activity since 2007. Also, we generated several programs, and international lithospheric programs, which I already mentioned, is one of the major our research program, which is a more than 40 years program. And this is a global geodetic observing system, one of the major program of the International Association of Geodesy. And other mentioned here, there were today existing programs, and IUGG contributed to development or even initiation of all of this, especially the World Climate Research Program, Integrated Research on Disaster Risk, and other. And this is a past our activity. I am not going, it's no time to go in details or other things. What we are doing in general in publication, we publish it every year annual reports, yearbooks, of the proceeding of the General Assemblies every 4 years. And we have a brochure, by the way, recently translated into Spanish. That's the first non-IUGG language, because IUGG is a bilingual union, English and French, and this first language we translated this our brochure into Spanish. That's already you saw this our activity. Michael showed this in special publications, what we are doing together with the Cambridge University Press. Or as I mentioned, we established a contact with the International Center for Theoretical, Abdus Salam International Center of Theoretical Physics. It is one of the events which we organized there, and we brought together the scientists from the developing world and the best scientists from the many geo-unions, not only from IUGG, from many geo-unions, to really speak about what is the future of the science education, especially in developing countries. And we also developed together with the ICTP, some programs outside of Trieste. And for example, this is in University of Rwanda, we organize special workshops. So that is what we introduced in 2014, and that's the first our honorees. And you see that we introduced gold medal, silver medal, they called the fellowship IUGG, and early career scientist awards. I would like to mention gender issue. I already mentioned when I came to the office, it was a 0 female scientist. The only the scientists. I am talking definitely about the leadership. I am not talking about the scientists who contribute to IUGG, and female scientists we contributed significantly. I'm talking about just the leadership. Yeah, and leadership, in that it's mentioned exactly here, Executive Office of Union in 2000 was a no female scientist. Today we are very happy. We have 25% female scientists. Our vice president, our member of bureau, and several others who are our best scientists and best people who contribute to the activity of the governing activity of IUGG. And we hope to 2030 have no less than 50% of female scientists in the leadership of the union. Why not? We have to convince the national and the members and association to nominate more brilliant scientists, female scientists who are around and to be elected for the positions in IUGG. That is a list of the general assemblies. You see how the number of the participants increased, and the last time was about 4,300 people in Prague. And in Prague, you know, sometimes the people ask, what is the difference between the AGU and IUGG? I'm telling you, know, guys, you are going to AGU really to deliver your talk and go back at home. But IUGG events not only scientific, they are cultural and scientific, because every time we go to one places in the world and the people enjoy that. You know, the people enjoy to go and drink one of the best European beer. You know, it was always during the all time 10, 12 days beer were offered this to the participant. I mean, it's but you know what is interesting? The Prague was the only place who hosted which hosted the General Assembly of IUGG second time. And the first time was the third IUGG General Assembly in Prague in 1927. You see here it's a participant of this leadership and participant of this General Assembly here. Another example, it is Moscow. At that time was the Soviet Union, and you will tell why you got these pictures, and I will show now. It is a Kremlin. It is a very high level of the General Assembly in the Kremlin, and that's, you know, there is about 2,000 to 2,500 people at the opening ceremony. And now I will show you why I have these photos, because of this gentleman. You see this gentleman, that is my father. He was a delegate of this General Assembly. That's why I have at home these photos. And now you can see how it was a General Assembly of IUGG there. We were honored in IUGG to have an Emperor of Japan who arrived from Tokyo to Sapporo to open the IUGG General Assembly in 2003. And you see our long-term treasurer who are sitting here, and also here it's Axel Hansen, who was a long-term treasurer of our union, wonderful treasurer. Well, these our associations not only developing activities within the General Assembly, but also they are doing these things in between General Assembly. It means we every 2 years generate some scientific assemblies for scientists. Sometimes more general, sometimes it is split between associations, but most recently they started to come together, several associations, not only 2, but several. For example, in 2017 in South Africa, we had 3 associations who contributed to the which came together to have their meeting. And thanks to Isabella Nzorge, our bureau member, who is present here as well, and she organized this wonderful event in Cape Town. I will just drop these things because you already see, but idea to show this, it's how IUGG develops the science policy. We are really linking many intergovernmental and international organizations together and go forward with a specific, here was a specific question, how science can contribute to reduction of disaster reduction. It was developed before the Sendai Agreement was accepted. Today's Sendai Agreement appreciates that science really should contribute and contributed to this thing. But we did a lot of activities, and thanks to Jaime, who participated with us also, and we developed this together with ICSO and the International Social Science Council. The report, special report, which was submitted to the Sendai, to the UN World Conference on Disaster Risk Reduction in Sendai, to the governments, 119 governments, telling about this, how science can contribute to the risk research and disaster risk research and assessment. And you see that the representative of, Secretary General of the United Nations and the Prime Minister of Japan giving the talk at this assembly. Also, we threw any major venues, and specifically I place this here because it was held in Mexico, and this is a global platform last year for disaster risk reduction. Was in May here in Cancun, and we met also in Cancun several organizations to speak again on this topic. And I am very happy that it's Jaime also participated, presented in Mexico here. We had a national members, like members from Germany, Ministry of Foreign Affairs, the Japan, the Council, Science of Council of Japan, and representative of intergovernmental institution to speak about how we can do together in terms of the disaster science research and risk assessment, which is a very important for, I think, all nations. We also producing reports to the J7, and this is a non-governmental scientific contribution. It is not something which they ask their own governments, but this is something which is related to non-governmental view or perspective on the 7 marine research aspects, particularly this one. And this last slide is related to what already Michael showed. It's how IUGG, through the International Association of Geodesy, contributed to the decision of the United Nations and introducing this permanent subcommittee on geodesy. Challenges. We have still a lot of challenges. Healthy future of the geosciences requires emphasis on fundamental science. We should not forget that the science for society is very important for us, but without fundamental sciences or basic sciences, we cannot develop really all these things which today we call science for society. Significant challenges face geosciences, which is one of them is to combine big data with the models. It's a big challenge, but that is something which we can do. Youth audience, it's very important for all us, for all sciences, especially for geosciences. And inter and transdisciplinary study, co-design and co-productive work will be something which we will do in 21st and beyond century. And that's very important. Sometimes the people tell us, what means it's interdisciplinary and transdisciplinary science? What we are doing normally within each association, we are doing disciplinary or pure research. What we try to do, and we are doing quite well, it is multidisciplinary research. What it means, we come together, we discuss some specific problem, we are going back at our university or research labs, and we are doing our part of the common problem. It's good, but today we need interdisciplinary research. If you will put in the blue water something yellow, you will receive green. It would be different color. We need to really come to the interdisciplinary research when we not only share what is our common goal, but we should go deeply and work together, contributing each other knowledge. Biologists contribute to our knowledge as a geoscientists, and geoscientists contribute to social sciences about this huge knowledge which we have. And social scientists have ability to make this quite easy contribution or quite easy interpretation of our very complicated science sometimes to public and to governments and those who are take a decision. Transdisciplinary, it is that when we bring science closer to society and closer to the decision making. That is the list of the wonderful events which will be around the world to celebrate the IUGG Centennial. And we are very happy that 2 events will be held in Mexico. One, it is a today event, and the next event will be in a few days at the Mexican Geophysical Union annual meeting. And we are very happy also that it's Jaime contributed to both these events and to develop these events. But you see also it's already the first event was held in China in 2 also places, in Beijing for policymakers and in Lanzhou for about 2,000 scientists who attended this meeting in Lanzhou. It was also a special workshop organized by International Association of Meteorology and Atmospheric Sciences in Japan, and would be 9 December AGU and IUGG Centennial event, and one on Sunday, full day for policymakers. And we invite the policymakers, scientists, and so on to this event. It would be Sunday, and everybody are welcome there. Information is available both on the website AGU and also IUGG. And the events will be in France, in Caribbean region, in Argentina, and in Jordan. And we are quite happy. And definitely already you saw these things, which is Michael showed, and you are very welcome to attend these another two major events, which we will hold next year. It will be IUGG General Assembly and the Centennial in Paris. Future IUGG international cooperation, that's the last thing which I wanted to tell. IUGG mission today is to advance, strengthen, and promote Earth and space science for the benefit of humanity through international research cooperation and education, and to communicate the knowledge to governments and policymakers. IUGG vision, future Earth that is environmentally sustainable and where societies are resilient against natural hazard. That's very important. And muchas gracias. Thank you.
Well, thanks very much, Alec, for the interesting presentation. And it's a long history of IUGG with many significant achievements. Yeah, we are proud to have the IUGG and the Council meeting here in Mexico. ¿Preguntas o comentarios?
I have a comment. I of course, enjoyed a lot your presentation. It was very interesting. When you mentioned the geophysical year in 1957 to 58, I remember that the meeting at the end of the geophysical year was in Mexico.
That's correct.
Yeah.
But there's so many events actually.
Yeah.
So many ones.
But actually, I remember it very well because Mexico is known by the tropical environments and deserts and all these kind of things. But at the end of the geophysical year, one of the aims was the global report on the glacier cover in the planet. So because of the reports were done in Mexico, Mexico had to make the cartography of all the glaciers, of Mexican glaciers, which were completely unknown before. Oh. So this was the first time Mexico had a report on glaciers.
Thank you very much. Great, yeah. To know, yeah, thank you.
This new group, the GeoUnions, do they have specific programs, or the programs from IUGG or INCUA will be incorporated, or how the GeoUnions work?
Yeah, thank you very much for this question. First of all, GeoUnions is informal organization. It is an organization we call the steering committee, which meets 1-2 times a year. This year we will meet it just in November. The next meeting it was 2 times. It was one in Paris because of the General Assembly of the International Science Council, and the next one will be in Turkey, in Istanbul, in November. Normally we meet to discuss something which really challenging problem for all us. And first of all, we're sharing what we are doing, where we can come together to do something. For example, one of the first joint projects was Geoscience in Africa. And all unions contributed to this, to develop. It was Uri Shamir, president of IUGG, who put this one forward, and many geo-unions at that time was 4-5 geo-unions, and they accepted it and they contributed differently, but together, I would tell, not interdisciplinary, but was a multi-disciplinary effort to promote geoscience in Africa. And not only geoscience, actually, because it was our association, which is IUGG, and Katie Veller, she was the president of IUGG, now vice president, but IUGG was president of IUGG. And they contributed not only to disseminate the knowledge in Africa about the geodesy and aeronomy, geomagnetism and aeronomy, but also they contributed through the international geophysical year, through the electronic geophysical year, to the how to improve electronic visibility of Africa, because Africa has a very bad internet connection even till today, you know. And at that time, it was 2007, 10 years ago, it even was worse the situation. And they brought together not only geoscientists but also the scientists dealing with the infrastructure, dealing with the IT technology and so on, and those who could help. It means that it's the policymakers in Africa and some foundations from European and US countries to speak together in Africa how these things can improve. I mean, even broader was this activity. No, it's not only. But normally we are going and we are trying to bring our efforts on a specific topic, like climate, water, energy, resources, etc. That is what GeoUnions normally try to do. Not always it's going, because we have no special funding for this. It is an informal organization, but it's very important that we come together and we generate one voice. In the international, let's say ICSO, time ago, this was one of the strongest group in terms of the different disciplines. The GeoUnions was strongest compared to, let's say, mathematical and physical sciences, or chemical sciences, or even some was a smaller social science grouping inside of ICSO. We were very strong because of we came together, we discussed together how we can act together, specifically in topics which was interest to ICSO and to other nations and intergovernmental agencies.
Okay, yeah, it's a really interesting development, and it will promote and facilitate the cooperation among the different unions. So it will be good. The collaboration with IUGS has always been very strong from the beginning, but yeah, it will be interesting to see what happens in the future with the GeoUnions.
Yes, with IUGS, you mean? Yes, with IUGS, we have a very good and friendly relationship for many years, since probably their initiation, they started in 1961 as a union, and since that time was very good relation, especially after we established a joint program. We have a really very good relationship. Most recently, for example, they established with UNESCO's International Geoscience Program, and they try also to bring the geophysicists inside of the program. And the last, for example, council had 2 council member geophysicists inside. One from Argentina, and myself also. We were 2 geophysicists inside of the mostly geological program. And that's also a very good sign of the geological unions, that they accept that this is a geoscience program. It should not be only geological, but it's bringing together the geophysicists as well.
¿Algún comentario? Bueno, si no, le agradecemos nuevamente a Lick y a Michael por las presentaciones. Y pues a nombre del Colegio Nacional, muchísimas gracias, y también a todos los que están conectados vía remota, que es en realidad la mayoría. We are also thanking to all of those who are following us in the streaming. Thanks, thanks very much again.
Thank you.
Thank you. Oh no, it's a real honor. Thank you. Bueno, muchas gracias.